All right, let's look at how we could answer a question on proportion. So, your mail order company advertises that it ships 90% of its orders within 3 working days. You select an SRS of 100 for an audit. The audit reveals that 86 of these orders were shipped on time. That is 86%. So, 86 out of 100. What is the probability that the proportion of on-time orders is 86% or less? All right, so the first important thing is to point out the important statistics here. So first of all, it does mention that it's an SRS, so that's going to be important when we state and check conditions. The other thing is our 90%, that is our population proportion. And then the 86% here, which is from our sample of our 100. So our sample is 100 right here. That is the sample size. And 86%, that is our sample. So that is our p hat. So let's go ahead and see how we would answer a question like this using all the conditions, mechanics, and conclusion. So looking at this problem, the first thing you want to do is you want to state and check your condition. So let's look to see what that would look like. So it did say that it was an SRS, so that's the first thing you want to check off. So it was stated SRS. Then what you want to take is our sample size was a 100 and our P was 90 right here. So we're going to multiply 100 times 0.9. We get 90. That is greater than or equal to 10. So that works out. And then the same thing with if our success is 0.90, that means our failure, which is our Q, is 0.1. So we're going to say 100 times 0.1, and that is greater than or equal to 10. It's actually equal to 10, so that is borderline. And then the third condition is we want to show that the population is greater than or equal 10 times n. So if we take 10 and multiply it by our sample size, which is 100, we get 1,000. And we will say there are more than 1,000 orders in the populations. So conditions are met, and we will use a normal model. Once we have a normal model, we can calculate the probability using the normal model. So given our p hat here, now our normal model contains the population proportion, which is right here, 0.9. That is our p. Now, if you remember, the standard deviation of the sampling distribution is going to be smaller. And how much smaller will it be? It will be the square root of P times Q over N. So this is always the standard deviation of a sampling distribution for a proportion. Now, when you work this out, you get 0.03. So then drawing the model, I have 0.90 as my proportion. That is our average. And we are going to count 0.03 as our standard deviation. Now, you don't need to fill it all in, since they said, what is the probability of 86% or less? And I went to the left, and I drew 2 standard deviations to the left until I got to 0.84. Now, looking here, 0.86 is right here. So when we do our z-score formula, we can see that we should get between -1 and -2. So plugging this in, our p hat is 0.86, our proportion is 0.90, and our standard deviation we already calculated is 0.03. Plugging this all in, we get a z-score of -1.3. Which makes sense, because if you look at our model, it is right between -1 and -2. So the region that I shaded here, that is the probability we are looking for. So then looking at our calculator, if we use norm CDF, or if you use a normal distribution table where you look at a z-score of negative 1.3, you could calculate the probability from a table. But using the norm CDF, we get that the probability of, remember, we always put in our lower bound first. So make sure to mark lower bound here. That is negative infinity. You could see that it is going right here is negative infinity. Then we have our upper bound, which is the question asked 0.86 or less. So that's our upper bound. This is our mean right here, which is the population proportion equal to the sampling proportion. And this is our standard deviation of our sampling distribution. So this is our standard deviation of the statistic. Looking at that, we get 0.0968. And then our conclusion, we will re-answer the question. The question asked us, what is the probability of the proportion of on-time orders is 86% or less. So answering the question, we will say the probability that the proportion of on-time orders is 86% or less is 9.68%. And this pretty much concludes how we answer a question like this.